Okay, welcome everybody, and we are now talking about some new parts of probability. In your handout you need to open page 11, so stop the video here for a moment, get this in front of you, where the discussion starts about random variables. A random variable is anything you can measure. There's an example here about bicycles being sold depending on the type of bicycles. Another example might be the grades that you get at school. Okay, these are discrete random variables, and if I measure a continuous variable like heights or temperatures, then you have a continuous random variable. Don't worry too much about it. At the moment we're going to be using a capital X to describe this random variable, and we'll go through some examples. Further down the page you have this example with a coin being tossed. So here my random variable is how many heads come up. Okay, and so I could obviously have 2 heads if I have if I throw the coin twice, or I can have a head and a tail, or a tail and a head, and a tail and another tail. So if I look at the probabilities here, and I'm just focusing on heads, the probability of the probability of no head, probability of no head is, if I look at this list, okay, if I don't get any head at all, that's only this outcome here. So that would be 1/4. The probability of 1 head, that will correspond to either this one or that one. So the probability is 2/4. And the probability of 2 heads that corresponds to this outcome, so that would be 1/4 again. So I can have the following probability distribution. That's what this is called. Either I have no head, or 1 head, or 2 heads. And the probabilities associated are 1/4, 2/4, and another quarter here. If this is confusing, it might help to think of an example here. What I'm really meaning is, for example, I could look at the probability of my random variable x being 2. This means this might make more sense. If my random variable is the number of heads, then I'm looking at the probability that my number of heads is 2. Okay, this might make more sense. This is the general case here. Right? Notice that the sum of all of these values is 1. That's what is being said here. Further down the page, you see a discussion of expected values. Well, if we have the probabilities being the same for every single occurrence of my random variable, then that's a special case, and in this case we simply multiply n, the number of times something is occurring, by its probabilities. I'll give you an example. Okay, but this case is, that's if p stays the same for each event. For example, rolling a dice, I will always expect that p of 2, for example, that means the probability of obtaining a 2 on the dice is 1/6. This won't change. Whereas in my example with the heads up there, you can see here the probability changes from one to the other. So on the next page we have an example. It's about rolling 2 on a dice. In this case, if I roll the dice 30 times, that will be my value of n. Okay, so here n times p, this would be n. This is the probability. I multiply the two. Okay, that was easy. What happens if my probability varies? This is therefore if P is not the same. That's what the next paragraph is about. So, in this case we talk about an expected value E of x, or mu, and that's equal to the sum of all, and this is what we're going to be summing, x times P of x equals x. Watch out, this is therefore one thing, yeah? This is not several objects here, the probability of x taking particular values, right? It'll become clearer if we make this example here. Basically, we need to multiply here x with the probability. So these different occurrences of x with their probabilities. So let's put that in a table. This is x times P of x equals to a particular value x. Okay, capital X and small x, right? And so if I multiply 2 times 1 over 36, I get 2 over 36. And here I get 6 over 36. Please pause the video now and complete this for yourselves. So here we go. Hopefully you have something similar to this. Okay, I've kept every fraction out of 36 because now it's easy to sum everything up. Okay, can you pause again? Sum all the numerators and divide by 36. Please do that now. And you should get that the numerator is 252, and 252 divided by 36 is 7. So that's my result. What does this tell me? It tells me that when I throw a pair of dice lots of times, the sum of the two figures I should expect is 7. That's the one that will come up most often. That's the one I should expect. Of course, other things can happen, but I should expect a 7 as the most likely outcome. So let's write this down. When you throw a pair of dice many times, comma, then you should expect a total of 7 to come up most often. Now, please, in your books, read the examples in the blue boxes on page 521 and 524. Thank you. Good luck.